Hi Math, I'm Andy. Today let's take a look at compound inequalities. Now before we begin our inequality work, just a special reminder, whenever you're solving an inequality and you use inverse operations, make sure that you switch the sign direction when multiplying or dividing by a negative on both sides. And so not every problem actually has to deal with this rule, but sometimes it happens. Here's an example of a compound inequality. And when I say that, you're actually looking for the words and or the word or, like a compound sentence in math that has and, or in English that has and, or but in it. So here might be an inequality. Let's say that I have negative 4 is less than or equal to x divided by negative 2 that is less than or equal to 0. So this would be an example of a compound inequality. One reason is because I have two inequality symbols at play here. This would be considered like an and type of inequality, and we can get into that in just a moment. But here's one way that you can solve it, and you might find that there are some shortcut ways for you to process this. But really what we're looking at are two separate problems that are kind of like merged into one. The first problem is the negative 4 is less than or equal to x over negative 2. And the second problem that we're actually looking at is the x divided by negative 2 is less than or equal to 0. So notice I split this up into the two kind of problems that we're actually witnessing here. And we call this a compound because we were able to squish it together. Like in English, a compound sentence kind of has two sentences that you bridge with the word and, or but. Now we're going to solve this using inverse operations just like we would solve any equation in math class. If I want to get the variable by itself, I use inverse operations to solve. And so in this case, I'm going to do the inverse of division, which is multiplication. So I'm going to multiply by negative 2 on both sides. When I deal with fractions, I like to write my fractions as well, so I know that, hey, I got a negative 2 downstairs and a negative 2 upstairs. They're going to cancel out, so I have my x. I know that negative 2 times negative 4 is positive 8, and I just want to remind us of this special rule that I just mentioned. Whenever you multiply or divide by a negative number on both sides, you want to switch that sign. So here the sign has an open mouth towards the x, and so that sign is going to switch around and it's going to face the other way now. And so this actually says that 8 is bigger than or equal to x, or x is less than or equal to 8. So that's going to be part of our solution that we'll worry about in just a moment. But let's look at the other compound part of our inequality. This also says that x divided by negative 2 is less than or equal to 0. So the same math to get x by itself, I have to multiply by negative 2 on both sides. The negative 2 cancels, and so that just says x. 0 times negative 2 is 0. And again, because I multiplied by a negative number, that sign is going to switch. So the mouth was opening towards the 0. The mouth is now going to switch sides and open towards the x. So I kind of have two answers. One says that 8 is larger than or equal to x, and one says that x is bigger than or equal to 0. When you solve compound inequalities, what you want to do is answer this on the same number line. So let's draw a number line because there's more than one answer for x. In this case, x can be 10, x can be 100, x can be 1000. And so because there's more than one number, we need to paint the picture on a number line to represent every possible solution. So x is bigger than 0. We'll say this is 0 right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll go back a little bit to we always want to include, kind of as much as we can on a number line. So I'll put a couple of dots there. So if x is greater than or equal to 0, that means that x actually can have the value of 0. So I'm going to put a closed circle at 0 to say, hey, that's what x can be. And all the numbers that are bigger than 0 are on the right-hand side. So this red arrow really represents this answer, meaning x can be any one of those numbers. Now I want to graph this as well. 8 is greater than or equal to x. So this means that x can be 8. So this is 4, 5, 6, 7, 8. X can actually have a value of 8, but it's going to be less than 8. All the numbers that are less than 8 are on this side. And so you notice that these arrows are actually pointing towards each other. They're headed right towards each other. And so this kind of combined is going to represent all of my answers. My answer really is that x is somewhere in between 0 and 8. And so if I wanted to make an answer kind of like what my compound inequality looks like, I could say that x is in between 0 and 8. So the secret to compound inequalities really is just solve both of the equations separately, graph them both on your number line, and see what you get.